Hello, I'm Mohammad Mamadou. Today we'll explain the design phase of our student clubs management system. So basically our system is about creating a centralized platform for student clubs, and students, student club administrative teams and student services will be able to use our system. Students will be able to view club activities, register for upcoming events, rate those events that they participated in, and also be able to apply for club positions. Student clubs will be able to create new events and vacancies. They will be able to view event progress in terms of student engagement, and they will also be able to answer inquiries that are sent by student services asking for specific type of information. And student services will be able to view clubs progress in terms of their student engagement for all activities, events, and vacancies. And they will also be able to send you inquiries to clubs asking for different resources. Well, for the architecture design, we decided to go on with three-tied client-server architecture. There are several advantages that made us make that decision. The first one is scalability. Because we expect our system to have more users each year, because of incoming students, we have to make sure that it should be scalable, and client-server architecture is a feasible option for that. The second one is interoperability. We have users from different operating systems that they use and different machines, so that this architecture is interoperable and can work smoothly with all of them at the same time. And thanks to three-tier, we have a separation between database server and application server. It makes our system reliable and consequently secure, so that in case we have some failure with application server or database server, the other remaining one will get unaffected. Between two-tiered and three-tiered client-server architecture, there was a trade-off we made. So adding this additional database server layer will, as a result, create complexity in developing that software and maintaining it. However, because of those advantages, it was worth to take that risk. And there was also another alternative, which is n-tied client-server architecture. uh, well, while it makes sense to have different servers for different parts of the business logic, as a result, we saw that it will create more network traffic because of the communication between those servers. Therefore, we decided to stick up with three-tied client-server architecture. Well, these are the components and functions of our system. The first one is Club Search and Activities View component. It enables students to enter search parameters and look for clubs and then view their activities. We have Activity Creation component. So we refer activity as event and vacancy, so that clubs will be able to create new events and vacancies. Event registration component. So students will be able to register for events. Vacancy application component. It enables students to view vacancy details and also provide their resume and motivation letter and apply those positions. We have event rate component. Students will be able to rate events that they registered for. Inquiry component. So it works from the side of student services and student clubs. So student services may make specific inquiries asking for information or club resources, for example, pictures for national holidays from student clubs, and student clubs from their side will be able to answer those inquiries. We have student engagement components. So student clubs, for their events, for each event, they will be able to see student engagement in terms of student registration and student rating of those events. And we have club engagement component. So it creates overall statistics for each club regarding their whole activities. including event registrations and event rates. That's all from my side regarding this part. Now I'd like to pass the floor to Fidan.
Hello everyone, I am Fidan Yusufova, and today I'm going to talk about software and hardware specifications and acquisition strategy of our group and our system. As you know, we have three acquisition strategy: custom development, package software, and outsourcing. And how do we plan to acquire such a system in our system? And our approach is simple yet still effective: package software. And as you know, package software could be suitable if the organization requirements align closely with the features and functionalities offered by existing system. And support offer faster implementation and lower upfront costs to rather than custom development. By the way, custom development involves building the system from scratch and to tailor it precisely to our organization's unique requirements and workflows. And let's deep dive into what's package pros and cons of package development. Package development offers flexibility and customization to meet specific needs and preferences, and enables integration with existing systems and infrastructure seamlessly, and provides the opportunity to incorporate cutting-edge technologies and innovative features. When it comes to cons are about require significant time investment and resources for development and implementation, and maintenance and cost can be higher compared to off-the-shelf solutions. And let's go to our hardware and software specifications. Yes, let's talk about firstly hardware. Hardware, we carefully selected robots equipped with memory and storage to ensure seamless performance even at the peak usage hours. And this servers running on the reliable Ubuntu operating system will serve as backbone of our system and handling data storage, application processing, and web hosting with ease. And as you see as hardware, we have here and for standard client, we have desktop or laptop, minimum 30 gigabyte random access memory and 128 gigabyte SSD. And for standard web server, it is minimum 8 gigabyte random access memory. And it's the same for standard web server. And it's a bit more for, I just don't see it. Just a second. Yes, a bit more for yes, standard. I'm sorry. Yes, standard database server. There's no problem. And yes, when it comes to our software problems, I mean specifications, and our software is equally critical in delivering a smooth and intuitive user experience for our clients. Whether they are accessing our system from desktop or laptop, we have optimized for compatibility with Windows 10 and macOS, ensuring that every user can effortlessly engage with platform using their preferred device. And let's see, as special software for standard client, our users can reach us from Chrome, Firefox, Safari, Opera as well, and standard web server, Apache and Nginx, and standard app server, Node.js, Java, or ASP.NET Core. And as a database server, it can be MySQL, PostgreSQL, MongoDB for database management system. And as an operating system, a standard client, as I said, can use Windows 10, Mac OS, and standard web server, app server, and database server will use Linux and Ubuntu.
Now I would like to continue with our physical DFT. Well, to draw the physical DFT, we made some changes on our logical DFT. For example, we added human-machine boundary around student services, staff, and club administrative team to separate human interaction from automated processes. We also added implementation details for our processes, data stores, and data flows. For data stores, we used MySQL, which is one of the most popular in one of the most popular relational database management systems. Well, for data flows, accordingly, we used MySQL records in most cases. Sometimes we used MySQL field in case that we use a specific attribute from that record. And for some data flows, we have HTTPS response. Those are not rather stored data, but as kind of system message. Therefore, it made more sense to use response, HTTPS response. And we also have some HTML for data flows. For forms, vacancy at form, empty forms, they return as HTML. So that's it with physical DFT. Now I would like to move structured chart. Well, actually for structured chart, we used our physical DFT very much. We started with context diagram and put it as parent model here. It has its own subordinates here with conditional line, meaning that these models are executed on specified condition. And after having these models, subordinate models, they also have their own subordinate models. And then we made some connections. For instance, we added loops to search clocks, create event, and create vacancy to show that those are repeated models. And finally, we added our couples. We have data couples in most cases, and sometimes we have control couples. For instance, for the ones that are forms details for create event and create vacancy, let's take an example. We have them as data couple, but in case that it's a confirmation message, it's not a particular data that is stored. Therefore, it made more sense to accept it as system control flag. Therefore, mark it as control couple. So that's it from my side. Now I would like to pass the floor to my group mate.
Now I will talk about the ERDs, data relationship entity, entity relationship diagrams. And as you see on the screen, it is our logical ERD from the last homework 3. But in that homework, I have written also added actually primary keys and foreign keys as well, but it wasn't needed. And because they are part of physical ERDs, what are their difference? And logical ERD focuses on conceptual structure of database, representing entities and their relationships without delving into implementation details. And it is used early in design process to capture business requirements. On the other hand, the physical ERD details the specific implementation aspect, like, as I said, primary keys, foreign keys, data types, and constraints. And it is utilized during implementation phase to translate logical design into a concrete database schema. And as you see, that was the logical one. Let's go to see what's our physical one. And as you see here, I have added data types and not null constraints. Not null constraint specifies that a particular attribute should never be null. should always be mentioned. And every record in the table has value for that attribute. And yes, as you see, I have written for integer for student IDs and not null, they are primary key. And also we have foreign keys, you have student ID, event ID, and club ID, vacancy ID. They are all integer and not null, with not null constraint. Then we have data types such as varchar, string, and text. And also we have date time for application date. For example, in inquiry, we have inquiry status, creation date, response deadline. And for inquiry status, I think there's a mistake because for inquiry status, there should be varchar, not date time because it's not date. And let's say it's 50. And those numbers were about, to limit the character size, character number. And that's all from ERD part. Thank you for your attention.
Hello, I am Sadi Khudaverdiyev. I will talk about interface structure diagram, low and high fidelity prototypes. First, I will start with interface structure diagram. The interface structure diagram is an interface, shows how each page are linked to each other and their functionality. We have three types of users: student, club administrative team, and student service staff. And we have 6 pages: student clubs, club description, events, vacancies, inquiries, and contact page. Now take a look at our application prototype on this page. On this page, the user can see all the list of the clubs in the system. I want to say in advance that the system can be integrated into any university or school digital platform. However, we have developed this prototype more in line with the myADA platform, which is the education platform of the ADA University. Therefore, we have set as one of the main goals that this new system should be compatible with the current system that we want to integrate. The ADA University logo will be located in the space you see at the top, at the header. I will explain this in more detail in our high fidelity prototypes. In the lower part, there are logos of the clubs. It's because we want to make the application more eye-catching and colorful. With the help of the search bar, the user will able to find the clubs he or she is looking for a shorter time. After selecting the desired club and logging in, the user will face with some options within the club. We see some options in the navigation bar. Currently, we see 4 buttons, and they are course description, events, vacancies, and contact. First, let's start with the course description. The course, this page is very simple. It only provides information about the club. If you look at the title of the page, the header of the page, it shows the name and logo of the club we are in. Then on the events page, we are greeted by several cards type boxes. Our student users, who have the largest amount of users, are facing this window. Here, the student can get brief information about the event by touching the name of the event and also the information button, and even register for the event by touching the register button. After clicking the name of the event, you can have more detailed information about the event in a new window and take advantage of other functions. Here we see the rate event function. The purpose of this to evaluate the event after the student has registered and participated in the event. On this page, we already see 5 sections in the navigation bar. We are no longer on the student page. This part 5 is inquiries, and I will talk about in the next pictures. This screen belongs to club administrative team, where they can create new events and edit existing events. Here also, the user can change event details both with and without logging into the event card. Now we have the vacancy part. On this page, the student gets accounted with the open vacancies offered by the club. After entering this vacancy, a student gets accounted with the details and enters the information and sends this to the club administrative team. On this page, the club administrative team can edit open vacancies. At the same time, they have the information of students applying for position by entering the club application part. And now we can get accounted with inquiry. This function is between the club administrative team and student service staff only. In short, the student service staff sends a request to the club administrative team to access club resources, and the club administrative team responds. In a high fidelity prototype, we use the consistent color scheme across all pages to maintain a cohesive look. The blue and white colors looks predominant and used for backgrounds, buttons, and text to keep the interface clean and so professional. Also, we choose legible fonts and maintaining consistent font styles and weights across all elements, including headers, body text, and buttons. Thank you for watching, and they are our references. See you.